So the first thing that you want to do, you have f of x equals 1 over x plus 4, is you really want to graph this, okay? If you already know what it looks like, you can imagine it, but we're going to do 1 divided by parentheses x plus 4 when you put that into your calculator. Okay, here we go. Shh. At -4, you know that x cannot have a value of y there. You know that because x, if you let x equal -4, you get 0 in the denominator. You might also know, or from graphing you can tell, that you have a horizontal asymptote at 0. You can tell that by using the horizontal asymptote test. If you plug in infinity for the bottom, it's 1 over infinity, which is 0, essentially 0. And so you graph this, it looks like that. There's a branch there, and there's another branch over here. All right, now once you have the graph, it's nice and easy to answer these questions now. So here we go. What is the limit as x goes out to infinity? So here I am, I'm going out towards infinity. What is this getting closer and closer to? 0. Okay. As you go out to infinity, as x goes to infinity, you're looking for the horizontal asymptotes. Okay. B, as we go the other direction, as we go on this graph out towards negative infinity, it's also, yeah.
It's going left and right because it's x, right?
Yes. Yes. Uh-huh.
Will it ever be going up and down?
Well, no, you always go towards an x value.
Okay.
But your graph might take you up. So the next one is, what's the limit as x goes to -4 from the left? So here I am on my graph, and I'm going towards -4 on the left. This is the left, and this is the right side of -4. My graph is going where? Down to negative infinity. Okay? On the other side of the graph, I'm running out of colors here, I'm going towards -4 from the right, and I'm going where? To positive infinity. Now, do those things equal each other? Does negative infinity equal positive infinity? No. So what do we say the limit as x approaches -4? Does not exist. Remember, for limits to exist, your left side limit and your right side limit have to equal each other. And then what's the limit when x equals 0? Just plug 0 in. Okay? You can do that on your calculator if you want to. Hit trace, plug in 0, you get 0.25. Or when you look at it and you plug it in, you get 1/4. Okay, let's look at the next one. The next one's a little different. It's got an absolute value thing there, so let's go ahead and graph that. So you have y equals parentheses x plus 1 divided by math num absolute value of x plus 4. And graph. Okay, this is a little bit different. Little bit. Yeah, so as you see, you still have an asymptote at -4, but if you hit trace and you follow this out, what is y getting closer and closer to? 0.7, 0.8. You can go to the table. You can follow it out as far as you want. It's getting closer and closer to 1. So here's what the graph looks like. You've got a vertical asymptote at -4 again. And then you have 2 horizontal asymptotes because the other side of the graph is following something else. So this one right here, there's a horizontal asymptote at 1, and then there's a horizontal asymptote at -1. Okay? And they're affecting the left and right side of this graph. And so when you graph this thing, it looks like this. And graphs are allowed to cross through horizontal asymptotes. That's fine. Because horizontal asymptotes affect one side of the graph, or they could affect the other side of the graph. And then the other one, it looks like this side. Yeah? It's underneath this one here. Okay? Do you see that?
So the bottom asymptote is only for the second?
Only for the left side, and the top asymptote is only for the other side.
The asymptotes are at plus and minus 2 or 1.
Plus and minus 1. You know how you can tell that? Remember the leading coefficient test? See that absolute value? Okay, when you have something like 2x squared plus 1 over 5x squared minus 3, the horizontal asymptote's 2/5, leading coefficient test. Over here, because it's an absolute value, it's going to be 1 over 1, but it's going to be plus and minus because of the absolute value. Yeah. So if this was a 2 right here, it would be plus and minus 2.
So we can just graph it.
Yeah, you can graph it. Yeah, if you can see it. But if you know that, that's coming, it's nice to know that too. Okay, so let's go ahead and answer the questions now. So what's the limit as x goes out to infinity? So we're going this way. What is my graph getting closer and closer to? Positive 1. As we're going out the other direction, this way, my graph is getting closer and closer to negative 1. Oh, I skipped something on the last one, didn't I? Did you notice that?
No.
I'm sorry. Horizontal asymptote, y equals 0. Vertical asymptote, x equals negative 4. My bad. Yeah.
Do we turn this in?
No. This is for you to study for the quiz tomorrow. Oh, yeah, there's a quiz tomorrow. See that? Okay, now, the next one is, as I go to negative 4 from the left-hand side, from the left-hand side, negative 4, I'm going where? Down to negative infinity. And from the right, I'm also going down to negative infinity. Okay? So just because there's an asymptote there doesn't mean that there's no limit. The limit exists, it's just the limit is negative infinity. Because they're both going to the same spot. They're both going down. And then when x is 0, you plug in 0, what do you get? You get 1/4 again. Okay, so the horizontal asymptotes. And by the way, I do mark off for this on the quiz. Please write y equals. Okay? Horizontal asymptotes are always y equals. Vertical are always x equals. Y equals, there's 2 of them, plus or minus 1. There's one for the right side and there's one for the left side. And then the vertical asymptote would be x equals negative 4. All right, pretty good? Yeah, really good. Okay, let's look at number 3 now. Number 3 is a little different too. Let's graph that. You can graph that on your calculator. You might even envision what's going to happen here if you know anything about factors. So you have x squared minus 16 divided by x plus 4. And when you graph it, it looks like a what? Just a simple old line. Okay? And then you're like, what? Did I graph it wrong? No, you didn't. If you go to negative 4, what's at negative 4? Yes. There's a hole in the graph at negative 4. Okay? Negative 4, let's see, negative 3.999999. It says y is negative 8. That's important to know. So over here at negative 4, there's a hole in the graph, and then it just looks like a basic line. And this right here is negative 8. And did you see how I got that? There's a couple of ways. One, you can factor this. Factor x squared minus 16 to x plus 4, x minus 4, and then reduce, and then plug in x equals negative 4. It's like you're taking the limit as x approaches negative 4 algebraically. You plug in negative 4 and you get negative 8. The other thing, since I had it graphed anyways, I hit trace and I plugged in negative 3.99999. That's as close to negative 4 as I can possibly get. Yeah. Really?
Yeah.
Do you have parentheses around x squared minus 16? Yeah, you gotta put parentheses around both the numerator and the denominator. Okay, so let's talk about this. As I'm going out towards infinity, what's my graph going towards? Infinity, yeah, it's going out to infinity also. As I'm going to negative infinity, this direction, my y's are getting lower and lower and lower down to negative infinity. The limit on the left-hand side of negative 4, it's approaching negative 8. On the right-hand side, it's also approaching negative 8, and so the limit is negative 8. And then what's the limit as x equals 0? You can plug 0 in to your calculator. You can plug it into your function. It's negative 16 over 4, which is negative 4. Okay, horizontal asymptotes, vertical asymptotes. Do you see any asymptotes on this graph? None. Okay, negative 4 is not an asymptote. It's a hole in the graph, very different. How do you feel? What kind of grade do you think you're going to get so far? F. Okay, great. C plus. All right, C's get degrees is what I always say. All right, next page. Might not get you into grad school, but, it'll get you degrees. Ooh, here's an interesting question. What are the 4 types of discontinuity? Okay, don't say it's a hole in the graph. It's called a removable. Yep. There's a removable. What other one do you know of? A jump? Ooh, that's one of my favorites. What were you going to say? Infinite. Mm-hmm. And one more, the one we always forget.
Yes.
Starts with an O. Oscillating. 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 It's that one that jumps back and forth between 2 numbers, never stops and lands on one. You don't like that one?
No.
I love it. All right, for the functions, numbers 4 through 7, we're going to A, find the points of discontinuity. Then we're going to name the type. And then we're going to write the y value of the function that would make the function continuous. Now, if that only works for removable. Okay, if it's infinite or a jump, you can't make a y value to make it continuous. It's only for a hole in the graph that works for. So let's graph this. First of all, can you tell where it's going to be a problem? At x equals what? X equals 3. That's going to be a problem. So you graph it. You can also factor it if you want to. This is x minus 3, x plus 2. And it's going to look like a line again. Okay? So what kind of discontinuity is that? It's removable. See how I removed it? Yeah? And then what would y equal if we wanted to make it continuous there? What'd you say? 5. How do you get 5? Plug it in. After you have removed the problem, you can now take 3 and plug it in.
So you have to do these algebraically?
You can, or, you can graph it. Did anyone graph it? I think graphing takes longer.
See that hole in the line?
You won't, but if you hit trace and go to it, there will be nothing there. So x minus 3, you know that you can't have x equal 3 because of domain. Yeah. So you go and you go, oh, it's a line. But when you hit trace and you go to 3, there's no y value. So what I would do, I would go 3.00001, and it'll give you 5. Or you go 2.9999999, and it'll give you 5. So, yeah. I like algebraically. You like graphically, huh?
Yep.
Okay, number 5. Do you remember what this one looked like? This one's fun. So what's our point of discontinuity here? 0. You're right. X equals 0. So 0 is our point of discontinuity. When you graph this on your calculator, it looks like this. And then you know what it does? It jumps up to here. Oh, I wonder what kind of discontinuity that is. It's a jump. There you go. Okay, and you can't make it continuous there by filling in a number for y. You just can't. All right, number 6. Well, we know right away x can't be 0, so that's going to be our problem. So let's graph this one. Sine of x, close parentheses, divided by x, and graph. Now, you might have thought it was oscillating, but it doesn't. Sine of 1 over x oscillates, but sine of x over x, what happens there? You hit trace, and you plug in x is 0. There's nothing there. So what kind is that? Removable. Now, what would y equal there to make it so that it's continuous? 1. Yeah. You can zoom in on it if you want to. You can also do that trick where you plug in 0.00001, but it's pretty obvious. It's 1. Yeah. The graphing calculator is really good for all these. Huh? That makes it so much easier. Yeah, if you're in AP Calc, I don't even think they have one. This way? I don't think they're allowed to have a calculator. I'm kidding.
Oh, you are joking.
Yeah. Okay, number 7. Ooh, look at this. There's a lot of different things here. Okay, so there are 2 points of discontinuity. Yep, 2 and -2. So what happens is, if you were to factor this, or you can graph it, whatever way you like to solve these. I like to factor. You get 1 over x plus 2. So at x equals 2, right here, that's a removable. It's a removable. Don't get these mixed up. What do you think x equals negative 2 is? Infinite. Yeah, it's going to be a vertical asymptote there. And if you don't believe me, you can graph it. And then to fill in the whole of the removable one, what would y need to equal? I would go to here, and I would plug in x equals 2. So this one might be a little tough to do on the calculator. So you plug in 2, you might not see what it is, but it'd be 1/4. Y would equal 1/4.
Wait, why did you use 2?
Because 2 is the removable one. So at 2, yeah, there's a hole in the graph at 2, so to fill that in, yeah. And then how did I know that was infinite? Because this is 1 over x plus 2, and so that would be a vertical asymptote at negative 2. Anything that looks like that is going to have a vertical asymptote. But you could graph the original if you wanted to. You could see. Here, I'll graph it for you. It's basically, it just looks like one of those rational function things with a hole in it. X squared minus 4, graph. Oopsie. Hit zoom 6 first. Okay. You can see asymptotes right away, right? You see that. It goes like that. So at x equals negative 2, there's an asymptote there. And then if you hit trace and plug in positive 2, there's a hole in the graph.